So for example number 3, we're going to draw a flag. So this is our flag on a flagpole. So this is a flagpole that holds a flag up. And when you have a flagpole that's really high in the air, sometimes what we do is we put in support wires. So now the support wires are usually equidistant or symmetrical, and they kind of form like this isosceles triangle shape. So this is a support wire, and what that does is it just kind of holds the pole in place. You'll see this on antennas and stuff too, and it just stops it from the wind blowing and stuff. So kind of holds the flag steady. All right. Now, in example number 3, we don't know the length of the wires, but what we do know is that they are both anchored 8.5 feet away from the actual pole. And so the question obviously is how much, how much, writing and talking is a challenge for me. How much wire is needed, and I'm paraphrasing, what's in the textbook is a little more formal, but alright, so how much wire is needed? Well, first thing I gotta do is solve for x. So there's a couple of things that we gotta think about, right? This is the section on right triangles, so these are probably right triangles, right? So that means that this is a 90-degree angle and this is a 90-degree angle. In other words, we have to assume that the Earth is perfectly flat and that the flagpole is perfectly straight. So then, if that's the case, then what I really have is I have a triangle that looks like this, where this is x and this is 8.5. Oh, one thing I forgot to mention is that we know that the distance from here to here, I forgot to write it, but the distance from here to here is 15.1 feet. That's kind of important. So now to solve for x, so we notice that this is a right triangle, so we can use the Pythagorean theorem. So to use the Pythagorean theorem, we have to identify what the hypotenuse is. And x happens to be the hypotenuse, which means that this could be A and this could be B, while the hypotenuse is always C. So now what I'm going to do is just plug that in. A squared plus B squared equals C squared. A is 8.5 squared plus B, which is 15.1 squared, is equal to C squared. So now this is just a matter of plugging and chugging. I'm just going to plug this into my handy dandy calculator as soon as I pull it up here. Thought I had it on there. Nope, got to turn it on. Alright, so I'm going to clear that out, burp, burp, and then I'm going to say 8.5 squared. Now the cool thing about this, the cool thing about this calculator is I could do it all in one step. So I've got 8.5 plus 15.1 squared, or 8.5 squared plus 15.1 squared hit equals, whew, that's a big number, 326. Equals C squared. And then, to find out what C, actually, I could change that to x, because we're finding x, right? We're plugging in the x for C. We just take the square root of both sides. So, we'll take the square root of that bad boy. Second square root of my answer, which is 17.32. I wonder if it wants us to round. we'll just say 17.3. Does anybody remember what that equals, or what that means? Doesn't equal. What's that mean? It means approximate value. So x is approximately 17.3.